Thanks, Mitch. Good afternoon, everybody. Like I said, my name is Michael Hartman. I'm the lead of the CSAT development team, which is the Corps Shoaling Analysis Tool. I'm fortunate enough to have in the room with me some members of that team, Rachel Bain and Katie McFerrin. Because you can see that there are a lot of names on here. We've had some growth on the team, and some people that have joined other projects. One of the names on here is an intern. But everything I'm going to be presenting today is, a product of this broader team's work. So I just want to acknowledge their efforts and all the hard work they put into making CSAT a better product. So, big overall picture, motivation behind CSAT. And it's usually, it's a story that we're all pretty familiar with, I'm sure, where the navigation infrastructure within our country is important to make sure products are moving through ports, supporting industry, supporting our national defense, make sure our waterways are protected, and operating conditions to support our navigation mission in the Corps. And in this, as things are always changing in our environment, just due to different changing environmental conditions, so our infrastructure is older, it needs to be maintained, and there are challenges and resources being available, being financial, monetary constraints. We're always being asked to do more with less. And with that in mind, tools like CSAT aim to help, capitalize or maximize the benefits, and maximize our use of our limited resources, get the most bang for our buck. Specifically, CSAT is an analytical tool that uses the hydrographic surveys that are being conducted and the surveys from the districts. They're uploaded to eHydro, which is an enterprise database. And we're basically being able to take those surveys and process them, analyze them, and obtain shoaling rates within the National Channel Framework, also set up by the districts. We have a few statements of need to help support this work. We're always interested in getting some newer ones on here. If anybody in the district is interested, you have a specific need that you think CSAT could help out, or if there's a current area that we haven't really focused on that you might want highlighted, please let us know. We're happy to maybe help get that statement of need process moving along. Seems that it helps get the tool in better shape for everyone to actually use it, and helps us get funding and everything set up so we can keep working on them. So, some of the capabilities of CSAT. So, in general, CSAT is now it's written in Python. It runs locally on the user's desktop. All the eHydro data is processed by the CSAT team nightly and prepared to be used within the CSAT tool itself. We take the bathymetric survey data and we sample it at a 10-foot by 10-foot grid, allowing for a regular framework for processing the data sets. And then the output products are shoaling rates, also in that same 10-foot by 10-foot grid, enable a reach level up to a district level, a project level, and district level roll-up capability. So that way, users in the districts can help better predict what their dredging requirements are looking towards the future. So we've had a lot of specific use cases here, supporting the Galveston district, New Orleans district, Mobile and Jacksonville, and it's highly here on Savannah. This is some work that I think was Katie McFerrin's effort, looking at within the Savannah Harbor project, seeing how CSAT applied for what the shoaling rates were before deepening of the inner harbor versus deepening after, and seeing what the changes in the shoaling rates are, and seeing if there were even changes in the overall regime of shoaling rates. So areas that were previously scouring that might be now filling in, or areas that were accreting sediment are now eroding sediment. And so this is to me, it's a really great representation of using the CSAT tool, not just using it as a click and go and just run, but building off of that capability to get new insights for the study area. One of the things I want to point out is that we commonly respond or receive questions or requests for help from folks in the districts, and I want to encourage that. We're always here and happy to help. If anything, makes me really happy just that people are using this tool. Like, it's kind of makes my day when I get one of those. If you have a question about CSAT, you could email me directly, but we do have a CSAT support email. So I feel like we're one of those cool projects that has that. But CSAT not only helps the folks in the district, but also using users at the headquarters level if they want to check to see what the original price might be district by district. So for folks that may not be familiar with what CSAT is, how things kind of happen, this is slightly updated screenshot. I think we're over 107,000 surveys, the latest and greatest. But all these surveys exist within the eHydro database. As part of a daily tasking order, the districts are responsible for uploading their before dredge, after dredge, and condition surveys in a timely manner. There's a certain window of how many days after the survey is completed before it gets uploaded. But once it's been uploaded to the eHydro system, it's then available for us to pull down and retrieve and include in our CSAT processing pipeline. The bed elevations are gridded and sampled at a regular interval, that 10 feet by 10 feet spacing that I mentioned before. And then they're arranged into this time stack, kind of space-time cube where in one dimension we might have, see the eastings and northings, the spatial component shown as a single green layer. If we pulled out that single slice, that'd be the equivalent of looking at the bathymetric service, basically the maps that get uploaded. And if we look at things in the vertical dimension here for time, extracting that would basically pulling out a time series at a single point in space. So at each pixel level, CSAT lists the time series of these elevations and calculates what these rates of changes are. So here we see through just an example of 6 different surveys. We might have surveys 1 and 2, so we are able to get a single shoaling rate from that. We pull out a combination of shoaling rates between surveys 3 and 4, 4 and 5, but also get a representative rate for shoaling rates 3 to 5. And while survey 6 here kind of exists by itself, we can take all these shoaling rates from the first 5 surveys and take that calculated shoaling rate and use that as a forecasting shoaling rate from the most recent survey, in this case, survey 6. An important thing in our CSAT process is that we are always trying to be aware of when dredging has occurred within our navigation channels, because we're interested in capturing the change or representing the change within the channels that's a natural response to the conditions, not necessarily a response to the anthropogenic influence of dredging. So we don't want, well, the channel might naturally get deeper. We're okay with capturing that, but not due to, cutter pipeline dredge, kind of coming through and deepening the whole channel. So it's really important for us to know when these vertical bars, occur in time series. If you're interested in using the tool or obtaining it, it's available by clicking this link here on the CIRP website, the products page. Mitch Brown does a great job for helping us maintain all that. Likewise, the survey data or the input data for the CSAT tool can also be retrieved from the same CIRP website on this other link. When you finish installing the tool, you set it up to run, and we generate certain output products, basically in 3 different classes. Typically we have our raster products, which include our most recently observed elevations, which might come just from the single latest survey. But if that latest survey was a partial survey, you'll also see the next most recent elevation at each pixel. So you get a full kind of composite picture of the most recently observed depth, but it may not just be from the single latest survey. Additionally, we have a shoaling rate raster, which shows what the shoaling rates are within the navigation channel. In this example, the pinks show areas that we're scouring with greater intensity, where the darker greens are areas that we're creating volume with greater intensities. We also generate certain tables, kind of each for the reach level. We have tables for the point by points results, which are average match mean file. That's somewhat equivalent to the a tabular representation of those rasters we saw, where we have the eastings and northings of the points. What the shoaling rate was for this is that pixel value that we were basing our collars off of. We're also showing what the range of shoaling rates were throughout that time series, most recent depth, showing how many surveys were available and how many of those survey pairs, how many individual shoaling rates were obtained. This sort of file is really good for kind of like the debugging or sanity checking, helping to understand maybe why you obtain certain shoaling rates. And then we also generate a dredging forecast or a volumes table that allows the user to look at certain cut depths and determine if you were to dredge today and you wish to achieve a certain depth of say 16 feet below mean level of water, you would need to remove 200 cubic yards of material. Similarly, if you we're interested, well, I want to go 2 feet deeper, say for advanced maintenance, which I think I lost my mouse, but you wanted to wait 1 year, then you can use this table to also estimate that about 2,100 cubic yards will be required to be dredged. So this sort of product allows you to examine different alternatives or scenarios based off of when you might plan on dredging, different depth considerations, et cetera. And the last of the reach level tables to highlight would be our survey volume table. So if you were to look at the difference between two different surveys in time, what's the net volume difference? And if those changes observed between the two surveys were to persist, say for an entire year, this is what your average shoaling rate would be, and your average volume change would be across the entire reach. Finally, we have some entire, roll-up tables or district level tables. The SPQ table, which is for the survey planning quantities. It's similar to what the volume tables were. It's just a nice kind of one-stop shop for all the different reaches that you ran for CSAT. Here we're looking at forecasting volumes out to 5 years at a 6-month increment to this authorized depth. And so you can use this to get the similar quantities that we showed before. In this case, some of these harbors just have a lot more volume to get back to authorized depth. But you can also look at things deeper or shallower. And finally, reach summary table. This is just the 30,000 foot level high viewpoint of for each reach. What's the average rate within the entire reach, and then what's the range of values basically from the raster. And these sorts of products that we've had within CSAT serve us well. They do a pretty good job of explaining most of the questions that people might have and understanding what the shoaling rates are and the conditions within their navigation channels. But oftentimes folks are interested in, well, are there things that we could do that maybe help explain things a little bit better or just help improve it? So over the last couple of years, or maybe the last time since I presented on updates to CSAT, we've been working on a feature wish list that folks from the districts, our customers and users of the tool have commonly asked for. And so I'm happy to spend the rest of this time talking about these new capabilities that we've developed, some features, and talk about when they might be shared kind of in a broader, live opportunity for everybody. So some of these things on the wish list: the ability to use data sets that are not in eHydro. We had specific requests about the child-sized LiDAR data. It offers bathymetry data, usually, or possibility of covering the navigation channel, as well as, a lot of areas, on the nearshore beaches and stuff. So while the nearshore beach areas aren't necessarily where CSAT was developed, specifically in mind, the fact that there exists data within the navigation channel framework that we might be interested in exploring, it'd be nice to incorporate these additional data sets. Charlene Sylvester on our team has done a great job as the experts of the JavaText data set in general, helped us develop the capability to work with that data. Number two is right up there, and one of the most commonly requested features, which is to use custom study areas. The way CSAT has been set up, let's say it's very rigid, but it's not very flexible in terms of looking at a custom AOI or study area. So sometimes real world applications, study area within the district will rarely align perfectly with the polygons established in the National Channel Framework. At times, their AOI might cover multiple reaches, say up to the entire project level or just a portion of. Sometimes it might be just less than a single reach. The reach that they were looking at might have been 30 miles long, but they were only interested in, say 500 feet or something. And while we've been able to work with those customers to demonstrate how they can do this using GIS tools, kind of on an ad hoc basis, we've built out the capability kind of as a post-processing step. It's an additional script that the user can run that will take a polygon for user-defined area of interest and then extract the relevant information from the larger CSAT runs. So that's something that, like I said, often requested, and we're happy to kind of have a solution for. The third issue is kind of one of the challenges that CSAT has faced is knowing when the dredging activities occurred. We've always, tried our best using the information available at hand. And something that's kind of been standing out, as an opportunity for us to capitalize on is the use of the DQM data from the Dredge Quality Management Program. It's basically a treasure trove of information that we've hoped to work with. We finally made some headway on that. Can show that. And then finally, is there a way to kind of enhance our current workflow, moving away from batch scripts? Because, I'd say something, just almost anything is better than a batch script outside of having to go and change hard-coded values in the Python code cell. That would be worse. Batch scripts oftentimes aren't much better. And so on some the actual things. So this is using CSAT kind of in a bigger sense than what we initially thought of. Before we were constrained to just using the hydro data and within the channel footprint. Thanks to Charlene Sylvester. She helped us tie in the JavaText data by querying the image CIRP feature service that the JavaText is hosting out. It's hosted on Amazon Web Services, and it's also, I think, in partnership with the NOAA Digital Coast project. Charlene has created a Jupyter notebook, so it's that reproducible science. Users just click through the cells, specifying their area of interest, going through the workflow, highlights which JavaText surveys are available within their study area, and then extracts that timestamp or each of those individual surveys, converts them to DEMs, and effectively creates a similar space-time cube that the eHydro data for the similar area exists within. As part of this process, she ensured that this aligns with the same sampling positions within the eHydro data, so that everything is co-registered. And one of the fun things within this utility is that she also included the ability to explore this kind of for like a data scrubber on a timeline that you can move through and visualize how the channel conditions or your study area conditions have changed over time. As this ties in with the CSAT workflow, we basically have these two space-time cubes. Almost thinking of our surveys arranged in time as two decks of cards, and we're now able to shuffle them together and then sort them both through time. So that way, if you wanted to tie in the JavaText data, that's now a possibility. I didn't go in and change this value, but the tech note that's documenting this overall process has recently been published. It's been submitted, which has February 25 just came out, and so we'll get that updated for everyone. And so I think this is a really good resource. If you're interested in using it and taking it for a spin, please let us know. We're happy to share it with you. And I think this is something that I'm really grateful for all the hard work Charlene put into this to make this a possibility. So thanks, Charlene. I think the last thing we highlight on this is that when Charlene was developing this, that she made a point of not only restrict, she helped us overcome the limitation of just working within the national channel framework. So when it goes to extract the survey data from the LiDAR data, it pulls everything from the channel AOI or from the user's AOI. However, for the current moment, the eHydro data is still limited to it being solely within the channel framework. So you are able to obtain shoaling rates purely from the Java text data, but within the channel will be from both sources. I think before we get this fully rolled out into say the user interface or something, kind of the production level for CSAT, we want to get some users some hands-on experience with it, maybe offer suggestions of, is this something that we want to be by default on always pulling in from the LiDAR data as well as the CSAT data, just pulling from both data sources, or do we want to default to using or starting with the eHydro data, but giving you the choice to check a box and say yes, I want to use the LiDAR data as possible. But that's that development. Looking at things maybe on a smaller scale, this is work from Kate Richards, who was an intern this past summer with us and did some great work. The tutelage of Dr. Rachel Bain, who helped kind of guide this through. So this is that example that I think I described before, where sometimes a particular study area may not align with the entire reach as laid out in the National Channel Framework. So if you're using just the single reach, you'd be left to this 15-kilometer stretch here in Brunswick Harbor. But if you're only interested in knowing what the dredging volumes are in a smaller section, CSAT, before what KR developed for us, was incapable. You were just left with these larger numbers in the volume tables and forecasting amounts. And so using our raster products and pulling from the data, and CSAT, she's able to then to regenerate our volume tables for portions of the CSAT data in your custom AOI. This is, like I said, going to be like a post-processing step. So that way you still have to run all CSAT for all these reaches, but then you could go back and run for any area of interest that you want, just from a shapefile. We hope to have that kind of implemented with some additional documentation next couple of months. And then moving on to our dredge detection. This has always kind of been, I don't say thorny topic, but an area that I've always wished that we could improve upon. I know we've always done our best. One of the surest ways that we found to, or maybe more reliable ways to identify a dredging event from the eHydro data is by referencing the survey IDs that the eHydro users register when they upload the data. As part of the survey ID, there's a 2-letter code that's meant to signify if this is before dredge, which we use the code BD, after dredge, AD, or condition survey, CS. And there are a handful of other codes that some districts have been using. And while that's been the most reliable, because we can point to this was an AD, therefore it's an after dredge, and we can treat it as such, we found that some of the practices that the districts have been using in uploading their surveys, that the label itself may not be completely reliable. Thinking of instances in New Orleans district where, like in Southwest Pass, they survey so frequently and they dredge so frequently that almost, so a lot of these surveys are going to be AD much more frequently than not. And so all those surveys are uploaded with a CS identifier. And so at that point, it falls upon us as the user of the data then to come up with alternative methods for identifying this dredge activity. We've tried to have a workaround before by looking at changes in the volume between 2 surveys and trying to come up with some sort of thresholding value that, if the net volume within a reach exceeds 50,000 cubic yards, then that would signify a dredging event. Or if the net volume changed by a certain percentage threshold, that, treat that survey as an after dredge survey. For the most part, that's been done kind of like a one size fits all solution, and we found that that's not really the best way to go. So we've been really interested in coming up with, how can we maybe fine tune this, instead of taking a wrecking ball approach and one single threshold parameter, instead, being more precise, as a scalpel and saying, per reach, what's the best threshold value to use. But again, we're falling back of the challenge of, I guess, knowing with any confidence that the dredging has occurred. And to do that, we've been able to make use of some of the DQM data through an API that the DQM team has set up for the CSAT team to use. And using this API, we're able to query for a given reach what days and what locations within the reach have been dredged. We're not able to, we're not requesting the entire DQM data set. We're not getting their 6-second resolution data with all the bells and whistles. We're very much getting an aggregated, anonymized data set that is just telling us on this date, these portions, kind of actually hex bins, kind of approximations of the area that were dredged. And so what that enables us to do is we can look at, let's say, a single point here in this figure, pull out the bed elevation time series and see how the changes occur over time. When looking at the DQM data, we can look at, I mentioned these hex bins, so how many of these hex bins over the whole reach report dredging activity occurring on that given date. And so sometimes we might have very small numbers, meaning just like a small portion of the reach might have had a dredge present and actively working. But other days we have large areas, so these higher values showing that the dredging has occurred. And we can actually see that there's a pretty good correspondence between when we have these high dredging events, or dredging counts, that they line up with when deepenings of the channel have occurred, which is really great because now we can have something to back us up and say, hey, look, DQM said there was a dredge working, and we see changes in the channel. So whether or not that the survey ID labeled this as an after dredge survey, we have something else that we can fall back to. This also highlights kind of another challenge. Well, DQM data is great, which we had it everywhere. We don't have it for all time, and we only have it as far back as the DQM data is available. The dredges that were operating, had their sensors, that they were equipped with the sensors. So we can't go back in time to before that data was available. And so looking, before 2020, we don't have that DQM data for our time series. And so part of the work that Dr. Katie Barron was working on was trying to use the changes that were being observed from, say, the single point of when we know dredging has occurred, to help then inform what our dredging thresholds, what's the typical change that we're seeing, whether percentage based or volume based, on these previous pre-DQM data availability times. I think this is a really great opportunity. Still not necessarily without its challenges, and I guess in terms of like implementation, because there are two kind of ways that we can approach this and incorporate this in like the final product delivered to our CSAT users. On the one hand, we can use the dredging activity to say, on June 1st in 2020, we had a dredge within the channel, but our surveys, the survey before this was back in February, and then the next survey was in September, and they're both condition surveys. The fact that we know that we dredged in June, we could say, well, let's treat that later survey as an after dredge and manually set that to an after dredge label. And that's the way that we've currently implemented the inclusion of the DQM data. It's certainly one avenue that we could, I guess, address the problem, but it does come with the side effect that that's going to enforce the dredging activity across the entire reach. instead of, I guess, a more precise area where the DQM data was actually detected. And so when looking at that, here these vertical bars represent when dredging activity was detected, that there are sometimes that we can have dredging activity within the reach, but it wasn't necessarily, matching up with overall, large changes, or increasing the depth within the channel. And so we can see that in this section, well, we've had a few dredging dates, but the mean elevations across the whole reach also increased. So, when looking at a pixel by pixel based approach, I think we're leaning towards, let's be more precise wherever the dredging footprint exists, then let's enforce that dredging distinction as opposed to the more complete or the reach level one. The one challenge that we found is it kind of makes interpreting our shoaling rates a little more difficult because within this overall reach level where we've been processing, we're going to have certain portions of the reach where had dredge activity, some didn't, and so I guess like the interpretability of the result, it can be harder to diagnose. If you get a weird shoaling rate, why is that? And so, we're definitely open to feedback and suggestions from users. Like, how would you prefer to have this? We could have it set up that our survey update tables that we include in our input data and that the user can modify. We can have that set up to already reflect the influence of the presence of the DQM dredges and set surveys following the dredge activity to be AD, or we can give the information to everybody and then allow you to manually toggle that on. Basically, an opt-in preference. Here's the information. If you want to use it, you can go ahead. I'm open. I think my stance is let's be more flexible. Let's give the user the option and be kind of more transparent about what choices are being made instead of just saying it's done. You have kind of limited control to undo that. But we'd love to get feedback from users as this kind of rolls out. If they want to test what the different options are, what those impacts. But we're really excited about this. We're happy that the DQM team was able to make this sort of thing happen for us. And we're still kind of testing out some of the edges with that. The boundaries, how can we make sure this is production level ready? Just being consistent with that API connection. I don't want to bog it down with every night requesting their entire data set. It can take a while to crawl through the whole thing, and just want to be responsible users of their data and the resources they are opening up for us. So the last thing I guess to highlight is the CSAT user interface, the new GUI and capability with the tool. More or less under the hood, everything's still the same under CSAT. This GUI, it runs based off of, again, using Python locally on your computer. And so it's going to be something that you use within your web browser. It allows you to set the runtime parameters that you would be able to do from the batch script. So you get the same control and functionality, but allows you to do some more exploring of the input data sets. And then eventually we hope to have it show you some more of these whiz-bang great visualizations that the team has been able to construct over time. And dare I take a risk? I think I dare. Not necessarily do the full live demo, but we can poke around. So you have the ability to select which district that you want to look at. You select your time range of when you want to start your survey data processing and your end dates that we can control. If you want to look at say pre-deepening of a harbor and post-deepening the harbor, you can do those selected runs. If you wanted to only run say a particular project, like this is Washington Harbor in the Buffalo district, or sorry, Wilson Harbor, you could do that. If you're not really sure where some of these things are or projects are within the district, you can use the interactive map. Thank goodness this is working. At least it's working live. So that way you can hover over particular reaches, examine the properties, make sure things work. With the new GUI, not necessarily, I wouldn't describe myself as an app developer, so I apologize if it's a little engineering-like. We all have certain design eyes, I think, or maybe there's a default sort of thing. But we're always, any feedback is great, how to make this better. I could definitely see this being that I want to select and grab just these reaches, and that would be my thing. So I think this opens up a lot more of like, you know, this is cool as it is, but like, you know, to make it better, you know, launch a list of ideas, send those my way. I will definitely be receptive and will keep me busy. All the information here is the same stuff that's already being served out in our reach table, which is kind of just the property tables from the National Channel Framework. So in case you're interested in interrogating further, then you can also explore what these surveys look like within eHydro. So be able to filter surveys based off of different types. If you wanted to look at just after drive surveys, which I missed that out. Maybe. Yeah, just after drive surveys. And then you can go and visualize what this looks like on the map. Look at that. Really taking some risks here by some of these features, but yeah, you can type in free response filtering on through this, so that way you're not having to manage a CSV file like we used to old times, have to manipulate things with the CSV deal. You can also manually change these whether you want to be used or not used. But here, for example, we can visualize this on the map of what the channel conditions are before, as a before dredge survey, and you can actually get what the depths are through the channel. And then here's the after dredge survey, and we can now see what the changes were. Everything is now deeper, which is great. One of the things that we found that this can really help with is sometimes when you're looking at your results, there might be a single survey, like survey comparison, that is yielding like kind of head scratching results. Like the volumes are not matching up with like similar volume changes. There might be something wrong with the data. And this allows you then to click and see, oh, hey, there's, for whatever reason, a bad or erroneous value in the middle of the channel. I can't tell you the number of times that seems to have happened. And usually the advice that we will give people is that you would then just disable that, exclude it from the overall analysis. So that way that value is not saying that you went from 50 feet of depth or something in one survey to, you know, -1 feet the next. So a little speed bump, and then back down like to 48 feet the following survey. And so that sort of thing would kind of throw a wrench into our shoaling rate calculations. And it's surprisingly hard to catch maybe certain cases where that has been happening. But this is just one more tool that the user now has at their disposal then to explore the data, just get a sense of, you know, for their particular reaches. And this, I think I've done a lot through here, but you can see different reaches here. Definitely going on. Yeah, so this is within the harbor here that we can check. Just larger zoom in, pan out, and I think, you know, put that on there, but we can, you know, kind of change these sizes so that we can get, you know, greater detail as you see fit. The additional control section, just a lot of these are the options within our batch scripts. You want to generate rasters, yes or no. If you have a custom reach table, unit performance table, or survey update table that you maybe already had existing for your previous projects, you can select that. Sample tooltip. I got to update those. But we're kind of in the beta phase of this, and we're looking for anyone in the district that would want to help us put it through its paces. Let us know where it works, where it breaks. At this point, let us know where it works. That'd be really good. I can probably tell you a few places where it's going to break. But these are all, again, features that in the batch script, you might have to uncomment a line or add this. It's kind of cumbersome, and it's a big pain in the neck that I really wish I would like to avoid. I hope that this kind of alleviates. Once you are kind of satisfied with this, you can, you know, save the configurations. That way, the next time you came in, if you had a particular district, certain reaches enabled, disabled, only certain reaches running, those get saved to a JSON file. So that way, the next time you can just load your configurations. That way, you might have only run this through today, 2025, reload that up, and you might have, you know, a few more months of surveys that you want to change, maybe what your window is. And then you can modify that. Click start, purposely disable that for the time being. But you would hit start and it's going to run CSAT like it would normally in the background. It's going to produce all of your tabular outputs, your raster outputs for use. And then say part 2 of this GUI, which is not ready for prime time, is all of the backend results, viewing the results within the same web browser through this. This is all done through Python. It's using open source libraries, panel. It's been a bit of a fun journey learning some of that. So I'm always happy to share my experiences with this. There's now there's a whole bunch more documentation on how to do this sort of thing, which is great for anybody that's interested in using this. So that is the end of the live demo. Getting back to the thing I planned on. If you're interested, let me know in the chat. We'll be kind of taking a look at that and getting some users, as well as just send an email to our support email. And one of the nice things with support email is that kind of helps us keep track of people who might be using our tools. So in case if we do have a new update, we might try to get like a CSAT users list, kind of like groups. That way we can share, there's a new update. Is it worthwhile upgrading to? Yes, usually. If we have any bug fixes, that sort of thing. Yeah, so kind of in summary, I was going to have a nice little roadmap diagram, and then I realized I'm apparently bad at creating those. So if you want to know about the CSAT roadmap, available now, which I don't think it necessarily was before, is our brand spanking new CSAT user guide. Thank you, Rachel Bain, for putting that together. It was say a labor of love. It's very detailed, very complete, probably the most complete description of what CSAT is, how it works, and things to watch out for that we've ever put together. Please take a look. Let us know what you think. If there are questions you still think might need answered. Our next update, that'll be coming later this week. It was supposed to be yesterday, but I kind of got up with these slides or whatever, is basically a workaround due to an update to the Conda management environment deal. And ACID let us know, I guess, a couple weeks ago, maybe a month ago or something, that due to a change in the software licensing policy from the company, kind of threw everybody in the scientific Python community for a loop. That now if you're in a big organization, whether you're academic or government, you got to pay for it. I don't know if anybody on the line knows this, but I'm pretty cheap when it comes to paying for the software. And that's not, I wouldn't want anybody else to have to pay for that if we don't have to. So we have tested out a workaround because Conda does get installed alongside ArcGIS Pro. We figure that most of our users, when they're exploring their raster outputs, are probably visualizing this within ArcGIS Pro. We know that ACID has, the Corps has that licensing agreement with Esri, so it's available for Corps users. We encourage people to, I guess, request ArcGIS Pro get installed, and then we have some updated batch scripts for those users that basically it's just drag and drop placement, and CSAT will run like it has always done before. In the meantime, though, we are working with ACID, CIO, or basically whatever ACID, if they rebranded, whatever, too, through the software approval process to get the free open source version of Conda approved, so that way everybody can use it. That's just jumping through their hoops and getting things signed off on. Saying mid FY, I'm hoping like in the next month or two, something like that we'll have our CSAT GUI in the hands of more users. We've been doing some revamping under the hood to make it more maintainable for everyone, kind of from the development side of things. And as we do that, we fully expect that different use cases are going to discover issues with that. So that's why we're putting in the beta. That feedback would be great from our users. We also hope to roll out the post-processing script, standalone Python deal for the custom AOIs. Coming later this year, we're going to have that the improvements for identifying our dreading events based off of the UM data, And also kind of later in this year, we also hope to have some more kind of documentation showing the validation of running CSAT, showing like which of our different shoaling rate methods, for quite a few. So which one is the best, where is the best applied, and answering some other outstanding questions like that from our CSAT user base. So I want to say thank you everybody in the room, thank you everybody online.